For the longest time, AI has felt a little bit like a magic trick, right? We'd get these absolutely incredible, sometimes world-changing results, but how the AI got there, well, that was often a complete mystery. But now, with large language models, or LLMs, it's like the magician is finally starting to talk. And these models, they aren't just powerful new tools, no, they're fundamentally changing how we even think about AI itself.
All right, so here's what we're going to cover today. We'll kick things off with that classic black box problem. Then we'll see what happens when the AI actually starts talking back. From there, we'll look at how we can get the AI to explain itself, and then how we can use it to explain our data. And finally, we'll wrap up by looking at what all this means for the future of explanation.
All right, first up, let's talk about the big problem that's kind of defined AI for the last decade or so. For all their incredible power, these models have basically been, well, silent geniuses.
I mean, think about it like this. Imagine you've got this brilliant code breaker who can solve any puzzle you throw at them. They hand you the solved code, perfect every time, but they just can't, or maybe they won't, tell you how they did it. That's pretty much been the reality for a lot of deep learning models. We get the prediction, we get the classification, the final result, but the why, the how, that's been completely locked away inside this super complex, opaque box.
So to deal with this, researchers came up with some really clever workarounds. You can think of them almost like forensic tools. You could use things like saliency maps to see which pixels in a picture the model was looking at. Or you could use feature importance to figure out which words in a sentence seem to matter the most. People even tried something called model distillation, which is basically training a much simpler, see-through model to copy the big, complex one, just to get a peek inside. But the key thing here is, these were all just indirect clues.
And this really gets to the core of the problem. Because in really high-stakes fields like medicine or scientific research, just getting the right answer isn't good enough. A doctor has to be able to trust the reasoning behind a diagnosis. A scientist needs to understand the pattern that led to a new breakthrough. In cases like these, the explanation isn't just some nice-to-have feature, it's literally the whole point.
And that brings us to the big revolution. Suddenly, thanks to large language models, that silent genius, well, it learned how to speak.
I know this sounds almost ridiculously simple, but it is an absolutely monumental shift. Think about it. We've gone from trying to interpret these faint, fuzzy signals and clues to literally just having a conversation. The ability to simply ask the AI to explain its logic in plain English? Wow! That just opens up a whole new universe of possibilities for understanding and auditing these systems.
But of course, this new power is a total double-edged sword. On one hand, the opportunities are just massive. We can interact with it, we can ask follow-up questions, we can have the AI explain incredibly complex patterns. But the challenges are just as big. The AI can hallucinate, just confidently invent an explanation out of thin air. These models are so huge and expensive that digging into them is really hard. And they can be super sensitive to the exact way you phrase your question.
Okay, so let's dig into the first big mission we have with this new capability, turning the LLM's explanatory power inward, to understand itself. You can almost think of it like a kind of AI therapy, where we're trying to make sure the model is being fair, safe, and logical.
And researchers are really tackling this on two different levels. First, there's what they call local explanation. That's like zooming way in on one single answer and asking, okay, why did you say this right now? But then there's global explanation, which is zooming way out to try and understand the whole system. It's like trying to map out all the internal circuits and pathways that actually make the model work.
So what this means is we can actually build transparency right into how we use these things. A really fantastic example of this is something called chain of thought prompting. It's so simple. You just ask the model to show its work, to lay out its reasoning step by step. And what's wild is that not only do you get a great explanation, but the model's final answer is often more accurate because it had to think through a logical path to get there.
And what about fighting those pesky hallucinations? Well, another key strategy is to stop the model from just relying on its own internal memory. It's a technique called retrieval augmented generation, or RAG for short. And what it does is it forces the LLM to go look up information from a trusted external source before it gives you an answer. It's basically the AI version of making it cite its sources, and it grounds the whole explanation in facts that we can actually go and verify.
All right, so that's using LLMs to explain themselves.
But now, we can totally flip the script. Instead of looking inward, we can point them outward and use them as these incredible, superpowered research assistants to help us make sense of our own messy, complex data.
I mean, just imagine feeding an LLM thousands upon thousands of customer reviews and all your sales data. It could just sift through all that unstructured text, all those numbers, and find a hidden connection, something a human analyst might take weeks to find, or maybe miss altogether. This isn't just about summarizing data. It's about discovering completely new, actionable insights that are buried inside it.
And this is where things get really, really powerful. See, the LLM doesn't just find the pattern. It helps us quantify it. It can show you not just that there's a connection between the words easy setup and sales of product X, but it can tell you exactly how strong that connection is. And just like that, a vague hunch turns into a concrete business strategy. But get this. Here is a truly mind-bending twist that came out of the research. Sometimes the absolute best way to use one of these giant, super complex LLMs is to get it to build a small, simple, and totally transparent model for us, like an old-school decision tree. And in some experiments, these simple little models, the ones built by the LLM, were actually more accurate than much larger ones. It's this incredible idea of using complexity to create simplicity.
So where does this all lead? Well, we're definitely moving way beyond just getting a single answer or a one-off explanation. The real goal here is to have a true, reliable, and deeply interactive conversation with our AI systems.
The big push forward right now is really happening on three major frontiers. First up, reliability. That means squashing the hallucination problem for good and making these explanations consistently trustworthy. Second is genuine knowledge discovery, using these LLMs to actually generate and test new scientific hypotheses. And third is interactivity, building these amazing conversational tools so that anyone, not just data scientists, can dig in and understand the data. So at the end of the day, the ultimate goal here isn't just to build a better calculator, it's to build a true collaborative partner. We're talking about an AI that doesn't just spit out answers, but actually engages in a real dialogue with us. One that helps us explore, helps us understand, and ultimately helps us make much better, more informed decisions.
And that leaves us with this final, really powerful idea. Something the researchers themselves call the holy grail of this entire field. Just imagine an AI that could not only understand something incredibly complex, like the global climate or the economy or a deep biological process, but could then reliably explain it to us in a way we can all understand. That is the truly transformative future that this new age of AI explainability is aiming for.